To collect your own data and participate in a global NASA experiment, you'll need to collect the following materials: Ziploc bags, a can that is 5 centimeters deep. Do not use a can that has a lip, as it will impact the volume. A permanent marker and a writing utensil. A digging tool like a trowel. Flags or markers. A scale with at least 0.1 grams sensitivity. A 250 watt infrared heating lamp with 1 or 2 bulbs that reaches temperatures of 65 to 90 degrees Celsius, and a graduated cylinder with a capacity between 100 and 500 milliliters. Before you begin, you will need to write down some important measurements. Turn on your scale and calibrate it according to the manufacturer's directions. Ensure that your scale is reading in grams and is zeroed. To measure the container mass of the Ziploc bag, roll the Ziploc bag to fit onto the scale. Put the Ziploc bag onto the scale. Ensure that the Ziploc bag is not touching anything other than the face of the scale. Record the mass of your Ziploc bag. You can round your measurements to the nearest tenth of a gram if your scale gives readings with more significant figures. Label your bag by indicating its mass and the date. The location of your soil samples is very important. Your sampling site should be representative of the surrounding environment. This is not an appropriate sampling site. Make sure your site represents the surrounding environment, is uniform in surface character, is relatively free of rocks, is not irrigated, does not have frozen soil, and is not under trees or shrubs. To learn how to design your sampling pattern, refer to the SMAP block pattern sheet from the Globe website. To begin sampling, you'll need a Ziploc bag and a digging tool. Clear the surface ground cover by cutting or removing grass and leaves without scraping the surface of the soil. Measure and mark the 5 centimeter depth on your digging tool. Dig about 5 centimeters into the soil. Collect a sample about the size of your fist. Remove any large rocks, and if you're up for it, remove any living organisms as well, without disturbing the soil. Seal and label the bag with the site location. Place a flag or a homemade visual marker to indicate your site location. For every 10th sample, you will want to use the can to measure bulk density. Follow the same procedure for clearing the site. Place the sample can face down on the soil. Distribute your weight evenly around the edges of the can and push the can into the soil. The bottom of the can should be even with the ground surface. Dig around the can to free the soil from any roots. Slide your digging tool underneath the can Then lift and flip all in one motion. Remove any excess soil by scraping the tool across the top of the can. Do not pack the soil in. Try to leave it as is. Wipe off any soil on the outside of the can, as this will impact your data. Lock in the moisture that is in the can by wrapping the can in plastic wrap. Use a rubber band to make sure the plastic wrap has a good seal on the can. We're now ready to take our soil back to the lab. Make sure to zero the scale before taking your wet mass. Allow the soil to occupy one corner of the bag so as to avoid touching anything but the face of the scale. Record this as your wet mass. Prepare the bag for drying by rolling the bag inside out as far down as you can without spilling any of the soil. Place the bag under the 250-watt infrared heating lamp and let dry for at least 2 days. Alternative drying techniques are acceptable provided that they dry the sample thoroughly and do not heat above 105 degrees Celsius. Sample bulk density is a measure of how dense and tightly packed a sample of soil is. It also helps us find the volumetric soil moisture of a given soil. To find the sample bulk density, you'll want to follow the same procedure of massing and labeling a new bag. Be sure to record this as your new container mass. Next, carefully unwrap the can without spilling any of the soil. Empty the can into the bag, making sure to scrape out all of its contents, and record the weight as its wet mass. Follow the same procedure of drying the bag for at least 2 days under the heat lamp. To record the volume of the can, fill a graduated cylinder to a point where you can record the volume. Remember, when you are using a graduated cylinder, always record the volume from the point of the meniscus. Dry off the glass protection guard and the lip of the graduated cylinder. Even 1 drop may impact your volume. Fill the can with the water you've measured. If the can requires more water, fill the graduated cylinder and record its initial volume. Fill the can all the way to the edge of the brim. Make sure the water has a flat surface. Your can should look like the one in the middle, not overfilled and not underfilled. Your final volume, or V sub F, is what's left over in the graduated cylinder. Since our can required 2 pours, we will include our first volume, or V sub 1, into our equation. V sub 1 plus V sub I minus V sub F equals the volume of the can. Don't forget that milliliters are equivalent to cubic centimeters. After 2 days of drying, mass your samples. You'll use the dry mass from the can sample to find bulk density. Bulk density is equal to the dry mass minus the container mass, which is the mass of the dry soil, all over the volume of the can. Bulk density allows us to go from gravimetric soil moisture to volumetric soil moisture. To find bulk density, you must use measurements from the can sample. Remember, your mass measurements will be rounded to the nearest tenth of a gram. Bulk density is measured in grams per milliliter. Gravimetric soil moisture is equal to the wet mass minus the dry mass, which gives you the mass of the water, all over the dry mass minus the container mass, which gives you the mass of the soil. The result is a mass ratio of water to soil, which is measured in grams per grams. Volumetric soil moisture is equal to the bulk density times the gravimetric soil moisture. You can use your bulk density from your can sample to find the volumetric soil moisture of all of your samples within the same sample site. Volumetric soil moisture is measured in grams per milliliter. Now that we have all of our data, it's time to upload to the Globe website. Thank you for contributing to the NASA and JPL SMAP mission. Now go on, get out there and have some fun.